Okay, good morning again. أهلا وسهلا وكل عام وأنتم بخير. Today's class is 40 minutes, so not many time to waste. Okay, so we were in chapter 6, if you remember. Chapter 6 is main two parts. The first part is interrupts. The second part is about the counters and timers. The interrupts, we covered it very well, and we did do live examples. Now we're going to start with the counters and timers, and they're related to interrupts as well. You can use them to make interrupts. This is a small or quick revision of what is a counter. كلكم درستوا logic, we know what is a JK flip-flop, right? A JK flip-flop, if I go, by the way, sometimes you don't see what I have on my screen, so شوفوني بس راح كنش سرحان. Okay. So a counter, an 8-bit counter, for example, is a register. We call it a counter register, and you learned how you make it when you studied logic. Okay, but each bit here, each bit holder is a flip-flop. Okay. One of the flip-flops you learned about is a JK flip-flop. This is a revision again. A JK flip-flop looks like this. It has a J input, K input, and a clock pin to trigger one to increment, or one to take the input and action on it. And we have Q as the output, right? And Q complement if you want here. A JK flip-flop will only consider the input and reflect it on the output. This means that this is an edge trigger. When there is a clock source fed into this pin, the clock, on a rising edge, the JK flip-flop will reflect the input on the output, on Q. If we put a bubble here, which means an inverter, this means that the output will change depending on the input on a falling edge. So this is the meaning of the bubble. A JK flip-flop truth table looks like this. Q at any time in the future, t plus 1, the current time, the next sample, on a clock, rising edge or falling edge في هاي الحالة, okay, on a falling edge, on a falling edge, could be like this. If JK were 0, 0, then the Q, the output at time t plus 1, will stay the same as when it was at time t. What? No change. The output will not change if the inputs here are 0, 0, and a falling edge happens. If they were 0, 1, then a reset will happen, which means the Q will become a 0. This is called a reset. If a 1, 0, the output will become a 1, set. 1, 1, here, 1, 1, on a falling edge will cause a toggle, which means invert Q that was there on time t, inverted. Okay? Regardless of the input, Q at time t plus 1 will stay as Q at time t if there is no clock, okay? No falling edge, okay? Regardless of the input, this will not change. So for a JK flip-flop, we have a clock source here on a falling edge. If we raise these inputs to high, يعني نعمل عليهم 1 1, okay, the output will be as follows. If the clock source is like this, and this is a revision again, okay, and we have a bubble here at the clock, which means the JK flip-flop will react only on a falling edge, right here. This is the clock source. Now Q, if assume initially it was 0, okay? If it was 0, it will stay 0 until a falling edge is detected. Then a toggle will happen, right? A toggle, which means invert. If we had a 0, it will become a 1. If it was a 1, it will become a 0. 1. And it would stay it would stay at this one, at this level, 1, until a next falling edge is detected, right? On a falling edge, if it was 1, a toggle will happen, so it will go down to 0. And it will stay 0 until a next falling edge. And then it will toggle, become a 1. And it will stay a 1 until we get to another falling edge. Okay, until another falling edge, and so on. You continue. Okay. Now, the frequency of this clock, okay, the frequency of this clock is 1 over this time, right? This is the time, the period of the clock. The frequency of Q is 1 over falling edge to a falling edge, right? Please don't forget to write your name and student ID in the chat if you didn't so. Okay? This time is this time plus this time, right? 2 T's, 2 T clocks, right? 2 T. So it will be the frequency of the clock divided by 2, right? Half of this frequency. Or the time would be double the time. Now assume we have another JK flip-flop, and the output of the first flip-flop feeds into the clock source of the second JK flip-flop here. And this is the clock, and the clock comes from the output of the previous, and these are tied to high, okay? And the output of the second, let's call this Q1, then this will become Q2. Q2 will be half of this frequency, right? So frequency of Q2 will be frequency of Q1 divided by 2. And this is what we see here in this slide. So if we have 8 flip-flops connected in a series like this, okay, then the clock input, this is the input, fed into this clock source of the first flip-flop. Then the clock source of the second flip-flop is the output of the first flip-flop. Then the output of the second flip-flop is the clock of the third flip-flop, and so on. All the inputs JK are tied to high. Then the frequency, the signal on Q0 will be half the frequency of the input. The frequency on Q1 will be half of the frequency of Q0, and so on. ماشي? Does this make sense? So إذا عملت لكم إذا جبت لكم سؤال بالامتحان, you like this way, right? إذا جبت لكم سؤال بالامتحان قلت لكم design a frequency divider. I receive a signal from an input using the microcontroller, okay? I want you to output a signal on port B5 with a frequency half of that frequency, or a frequency divided by 4, or whatever. Maybe a programmable frequency divider. Okay, based on this concept. And then this is the counter. It has a clock source. We decide the clock source. We talk about it later. You can write this register with initial value, which means you load it. You can write to it. So if you write in it 000, then it will count from 00000 to what? To 11111. An 8-bit counter, can count from 0x00 down to 0xFF, right? يعني من 0 to 255. تمام? After the 255, when a clock is detected, this will overflow and go back to 0. And if this counter overflows, we can, if it's an internal counter like timer 0 we have in our microcontroller, it is a counter, we can make an interrupt occur on this overflow. Now, you saw that the counter counts from 0 to FF, and you saw that we can, the clock source, okay, if we know the frequency of this clock source, yani we know when a falling edge is going to happen, right? Or a rising edge. So we know when this is going to increment. So if a falling edge comes every 1 microsecond, then this overflow is going to happen every 256 micros, right? Right? So we know when an interrupt can happen. If we change the speed of the clock source, we can change when the overflow is going to happen, right? And play with this time. Another thing, if you make the counter start with 0x0f, it's not going to go count 256 times before it's going to overflow, right? Because it's already half the way. It's going to count from 0001111 to 11111111, then overflow, right? Yani 128 to 255. Then it will overflow, right? 128 times. So 128 times, if we work on the same frequency, 1 microsecond, okay? So 128 microseconds before it overflows. So if we also, there are two ways to change when this counter is going to overflow, by changing the clock source frequency and by changing the value where the counter starts counting from 0, then it's going to do 56 counts before overflowing. If it's 128, then 128. If it's 250, then after 6 clocks, it will go overflow, right? Then 6 microseconds, and so on. That's why a counter is also called a timer. Okay, a counter is also called a timer because you can use it for timing. Okay, so when we use a counter as a timer, it has many useful applications. Many useful applications. Assume that we have a counter. Well, we know that we have a counter called timer 0, right? And we can make it count with a certain speed, play with the clock speed, and so on. Okay, we can use it to measure between two events. We can say, okay, whenever a rising edge happens on port B pin 0, which is the external interrupt, maybe. Okay, go read timer 0. Timer 0 in the background is counting. And then when another rising edge, read it again. Then figure how much counts it counted. And you know each count takes 1 microsecond. So, right? So you can measure time between events. You can, and the event could be two rising edges, or a rising edge, then a falling edge, right? If you capture the timer 0 based on the external interrupt, you can set the external interrupt to happen on a rising edge. Then when you're inside the interrupt, you set it to happen on next time on the falling edge. And every time here, you read timer 0, then here you read timer 0 and calculate the counts between them, right? And we talked last time about this, how to change when the external interrupt happens, if you remember. Which last time, the one before. See this register, the option register. We're going to come back to it now. But there was a bit here called bit number 6, interrupt edge. The default is 0, so the external interrupt happens on a falling edge. But you can also make it on a rising edge by setting this bit to 1 in the option register. Remember the example when we had the LEDs shifting back and forth, and when we pushed the button, it stopped the shifting and started blinking? It was an external interrupt example. If you forgot, go back to the recordings. طيب. No questions? Easy stuff, huh? طيب. So many useful applications. We're going to see more applications for the timer. We can do hardware-based delays, measure timing between events. We'll do a few examples here. So let's learn about timer 0. Timer 0. Timer 0 is a register that is placed in the RAM. In the RAM here at address 01 in the data memory in bank 0. The option register that we're going to deal with, we talked about it last time as well. We're going to deal with it in depth here, is also address 1, but in bank 1. Okay, this is bank 0. Okay. And the interrupt configuration register that is present in the two banks, this is the one where we have the interrupt flags and the interrupt enables. Okay. So let's learn more about timer 0. So timer 0 is a counter. Hi, timer 0 is, شايفينها? This is the same thing. It has a clock source. It overflows. You can read the value of the counter or the timer or the register. It's a register located at address 01. You just go read it. And you can write it. You can write an initial value in it before or during the count. Okay, so it's connected to the data bus. You can read it and write it by software. Whenever it overflows, there is a flag that raises called timer 0 interrupt flag. Where is this present? In the int con register. Okay, int con register. طيب, هلا the clock source that is used to increment this timer, where does it come from? Let's start from here, from most left. There is a bit here on, this is a multiplexer. There's a bit called timer 0 clock select that is present in a register called option register. هذه شفناها المرة الماضية. It's here down there. See, option register. And we write it like this. Option, okay. Come on. Option underscore reg. Okay, and it's also in address 1, but in bank 1 of the RAM. Okay, so timer 0 clock select is this bit. You select the clock source that's going to be used to increment this timer. If it's 0, so you set this in the option register 0, then the clock source of the timer will be the oscillator clock divided by 4. And what is the oscillator clock divided by 4? It's the instruction cycle clock, right? Oscillator clock divided by 4. So if I have an 8 megahertz clock oscillator, then the clock that is going to increment the counter is 8 megahertz divided by 4 equals 2 megahertz. If you set this to 1, then the clock source is going to come through this one here. What is this one? Okay. Through a pin on the microcontroller called timer 0 clock pin that is shared with port A bit 4. Okay, this is a pin. This is the microcontroller, the 16F84A controller. There is a pin on port A4. You can put a clock source here. This clock source could come from an external oscillator. It can come from a function generator. It can come from a push button that you push or it's pushed automatically when a door is open, whatever. Okay, right. So this is an external clock source that comes through a pin shared with port A4. Right. This is an XOR. This bit, timer 0 select edge, is also a pin in the option register, timer 0 select edge. That is also, the default is 1. Timer 0 select edge, the default of it is 1. Increment on high to low transition. High to low, يعني على falling edge. But you can go and make it a 0. You can make it a 0. So the increment will become on a low to high transition, على a rising edge. Okay. So if you do this bit, you make it a 0. This is an XOR. So whatever the clock coming here, it's going to pass as is. So anything you add XOR it with a 0 is going to stay as is. If you XOR it with a 1, a 0 will be converted to a 1, and a 1 will be converted to a 0. So it was like this. If this was the clock, taking it through an XOR, a 1 is a 0, then a 0 is a 1, a 1 is a 0 is a 1. So you're flipping the clock basically, right? So if the increment used to happen on a falling edge, now it's going to happen on a rising edge. تمام. Okay. Then either the clock source was the oscillator clock divided by 4 or an external clock source. It's going to come here. You select it through this bit. There is a PSA bit here that is also present in the option register, PSA, which is called the prescaler assignment bit. A prescaler is the first 3 bits here in the option register. If they are zeros and you assign, you choose to use a prescaler, okay? You make this bit a 0, the PSA. Prescaler is assigned to the timer 0 module, which means this bit will be, we're going to use this part of the table. These bits will be used to divide the frequency of the clock source by this number. So if you make them 0, 0, 0, and you assign this you assign this bit to timer 0, and you wrote a 0 here, then the clock source is going to be divided 1 to 2, which means if my oscillator clock was 8 megahertz, okay, then what's going to come out to here is 8 megahertz over 8 megahertz. If this was 8 megahertz, then this is going to be 8 megahertz divided by 4, which is 2 megahertz. Actually, 2 megahertz. And you have the choice to take it as is, 2 megahertz, or you make it go through the prescaler. And if the prescaler was 0, 0, 0, these 3 bits, the 2 megahertz is going to be 1 to 2, 1 to 2, which is, yani divide the 2 megahertz by 2, فبتصير 1 megahertz. Okay, 1 to 2. If the input was 2 megahertz, then 1 to 2 means that the output will be 1 megahertz. If you make these 3 bits 0, 0, 1, then you're dividing by 4. So half megahertz, 500 kilohertz, and so on. So you can divide the frequency. Dividing the frequency means multiplying the time, and making it slower to increment the timer. Okay, making the increment of the timer become slower. Now, if the PSA bit is set to 1, then the prescaler here is assigned to the watchdog timer. Okay, and the timer 0 clock will be taken as is. So if this is a 1, then this 2 megahertz will be taken as is. If it's a 0, it will be prescaled, yani frequency divided by a scaler. Okay, yani slow down the increment. Then there's a circuit here to synchronize. You have external clock sources. It could go out of sync. So to synchronize it with the internal instruction clock source, it will cause a delay of 2 clock cycles. Then, depending on the speed of the clock source we selected here, prescaled, this is going to count. Then when it reaches its maximum, 255, because it's 8-bit, it's going to go back to 0, yani overflow. The timer 0 interrupt flag will become a 1. Now, if you enable the timer 0 interrupt enable in the IntCon register, this will cause the program counter to go to the interrupt service routine. Okay? So you can cause an interrupt every amount of time of your choice by enabling the timer 0 interrupt first. Okay, enable the interrupt. Then choose your clock source, choose your prescaler, load the timer 0 with an initial value, and you choose when it's going to overflow. So you choose when the interrupt is going to happen. طيب. If you understand this very well, I'm going to go do an example, a real demo. We're going to update those. اسأل مين بده يسأل؟
أنا قيس، ممكن سؤال بس.
قيس.
لو أنا استخدمت external clock برضه بقسمها على 4 أول إشي قبل ما أستخدمها.
Here, if it's here.
مثلا لو أنا هون جبت.
لا it's gonna pass as is. ما بتقسمها على 4. No. As is. بس if you choose a prescaler here, yes راح تقسمها على الرقم اللي بتختاره بالprescaler. Okay.
تمام.
Okay. Let me see if anything is missing here. So you saw here timer 0, option register, interrupt configuration register, timer 0 configuration, and we're done with this option register. Timer 0 overflow, when it reaches, it's an 8-bit register. When it reaches its maximum to 55, it will overflow. Many usages we can use for timer 0. We can use it to generate hardware delays. شو رأيكم نعمل example here? Remember our code. Remember our code we wrote last time. شايفين هذا الكود? The project we did last time. What was it doing? We used to shift the LEDs on port C left, right? 7 times, then right 7 times, right? So we had the 8 LEDs on port C, and one LED going left, then going right, going left, and going right. So I think I still have it running. If I stop sharing, it's telling me the internet is unstable. Okay. Trying to get that bar. Stop sharing. Remember this example? Remember these LEDs, shifting? And we did a setup when an external interrupt type to port B bit 0 is pushed, then the shift stops, then we blink these 10 times, inverting any 10 times, 5 times on high, 5 times low, then we go back to shifting, back and forth. See the delay between the shift, shift. Remember how we did this delay? Okay. Do you remember how we did this delay?
دكتور استخدمنا الديلي فانكشن اللي احنا كتبناه.
بس كتبنا هذا الكود صح؟ We just wasted time. See this delay? This is what we did. We called a function called myDelay, right? Here in the shifts. And this was just wasting time. Just making the CPU busy, incrementally for 50 times inside it, increment a for loop 2,000 times, writing a memory location over itself, another memory, just wasting time, making everything busy. And we don't know exactly how much this time took. So, تقديري. We just played with these numbers to make it look good. How much is the exact time? We don't know. طيب, how do we do exact timing here? We can use timer 0 to do that, to generate hardware-based delays, because that timer 0 is a hardware, it's a register, and it's incremented based on a hardware clock, either or an external clock. We can make you a function, a delay function based on timer 0. شو رأيكم نعدل على الكود هذا و replace this delay delay we know exactly, مثلا 500 milliseconds. How about we do that? By using the TMRO overflow interrupt. Let's do it. Let's do it. I'm going to copy the code, start a new project. So not to waste time. Okay, I'm copying the code. I'm going to go new project. Okay, we still have 3 minutes, huh? Here, demo 7. Let's call it hardware delay, based delay. Okay. Next. Finish. Okay. So I'll just go paste that code here and we update. That's okay. Where is this is it? Which one? Is it this one? Yeah. So let me close the old ones. Oh man. I forgot which was the
دكتور مكتوب فوق
project.
ديمو 7 لما
لا عندي أكثر من page هون مفتوحة. You know what? I'm gonna build all projects. Then I close all and open our project. Okay, close project group. Okay. Okay, restart. Looks like it's not gonna any time, 1 minute left. We're just gonna talk about the idea and we write it next time. Okay. Open the project. Class demo 7, open. This is it, okay? So what we're gonna do, and when this is for the interrupt service routine. So we're gonna use also multiple interrupts. This is something we talked about last time. If we have multiple interrupts, what we're gonna do, we're gonna replace this delay. We're gonna do exact 500 millisecond delay. So how do we do that? We're gonna use timer 0. Make timer 0 count in a speed and overflow exactly after 500 milliseconds and take us into an interrupt service routine we write here that raises a flag only after 500 milliseconds. And here we just wait for that flag to rise. Okay? That will be an accurate delay based on the hardware, timer 0 hardware and clock. Okay, time's over. So we'll do this next time, inshallah. Thank you very much. You can stay for questions if you want.
دكتور
Okay, I'll be available, but let me just stop the recording for a second. Oh. Thank you and see you Tuesday.